Okay, so we're going to go over 4.2, which is solving systems of linear equations by graphing. So first of all, a system of equations is just more than one equation. That's it. Okay, so it says explain the differences between an equation and a system of equations. So if you think about your like digestive system, if you think about your, I don't even know, every other system, each of those systems contains one or more organs. So a system is more than one thing working together, right? So a system of equations is just more than one equation working together. So the very first method we're going to use is by graphing. So it says fill in the blanks to describe the and find solutions of a system by graphing. So the solution of a system of equation, sorry, the solution of a system, sorry, I'm lost, is the blank where the two lines blank. Okay, so that's it's where the lines intersect, and you're going to hear me say intersect over and over and over again, right? So that's where they intersect, and it's the ordered pair or the point. So I'm going to put point / ordered pair. Okay, and then it says, so if you look, this is a system of equations right here. How do I know? Because there's two lines, okay? And then again, it's the point where they intersect. So first you got to find out where they intersect, and you're like, oh, they intersect right here. And it's like, exactly. So right here is not a very good description of where they meet. So we need the actual location. And so now we just say the X value is 4, the Y value is 4. So your solution is 4, 4. Remembering that the first number is X, the second number is Y. So put an X in the correct column to identify the number of solutions for each graph. Okay, so there's 3 types of ways 2 lines can sit on a plane. A plane is like your coordinate graph, right? The X and Y axes. So they can look like this, where they're parallel and they don't touch. They can look like this, where they intersect. And then they can look like this, and you can say, Ms. Johnson, I only see one line. So I need you to know that there are 2 lines on here. They're just, one is on top of the other. So the other one is playing hide and go seek right behind it. So so again, the most important part whenever you're looking at a graph and we're looking at a system is where they intersect. So here you're like, oh, they intersect right here. Very good. How many times? 1 times, no times, infinite times. And you're like, oh, 1 time. Okay. So we put a little X there. Now, what about this one? How many times do these 2 intersect? And you're like, no times. Good. That's called no solution, meaning there's no point where the 2 lines share. Now here, this is an interesting one because they're literally playing hide and go seek and they're following each other. It's infinitely many solutions, meaning every single point on this line is a solution to this system. As opposed to here, there's only 1 point. There's only 1 point. Here, there's no points. Okay. And again, if you remember from our last thing, a solution is just where when you plug it in, it makes the sentence true, right? Okay. So we have this problem. Gina has 32 items to ship and 11 boxes. The large boxes can hold 4 items and the small boxes can hold 2 items. Gina has exactly enough boxes to hold all of her items. How many of each type of box does she have? Okay, so we're going to just break down this problem. So Gina has how many items to ship? How many items is that? And you're like, oh, it's 32. Very good. So we write it 32 in there. How many boxes does she have? And you're like, oh, she has 11. And the large ones contain 4 and the small contain 2. So 2 items will fit in the small and 4 items will fit in the large. And what are you asking to find out? You're asked to find out how many of each type. So go ahead and write that. So let X be the number of small boxes and Y be the number of large boxes. Now you need to write an equation to show the number of total boxes. So here, what you're going to do is you need to organize your information. And so whenever I'm organizing information, I tend to use a table. because that always helps me. So I'm going to make a table that maybe looks like, I don't know, this, sure. So over here, we have, let's see. So here, this is small, and this is large, and this is boxes, and then this is number of items in each. Okay, so then you can play totals as well. Okay, so this is just going to help me organize my information just a little bit better. Okay, so let X be the number of small boxes. Okay, that's X. And Y be the number of large boxes. And now we just want to fill out the rest of this. Okay, so how many boxes are there altogether? So again, I should have added another box over here, column to the right. Okay, so here, this is going to be total. So how many total boxes do we have? And you're like, oh, 11 boxes. That's right. Now, what does this mean? Now, let's pretend I had one small box. How many items are in, wait, not in each, in number of items. Yeah. So how many, so, I moved it. Let me move this back. Sorry. Okay. So, how many, if I had one small box, how many items can I ship? Well, you're like, well, you said that 2 items can fit in each box. So that means 2. You want me to put a 2 here? Not quite. So what if I had 2 boxes? And you'd say, well, how many items can I ship now? And you'd say, well, now you can fit 4 because 2 times 2 is 4. And then I'd say, okay, well, what if I had 3 small boxes? And you'd say, well, it'd be 6. So every single time, if you're noticing, you're just multiplying 2 times whatever number I give you. So if I give you the number X, how many items can I ship? And hopefully you say, well, 2 times X, also known as 2X. So the 2 comes from how many items I can ship for each box. X comes from how many boxes I have. Similarly, we'd go through that same process and we get 4Y. How many items do I have total to ship? I have 32. Okay, 32. So then from here, so this is basically my equation. So I'm going to say X plus Y equals 11. 2X plus 4Y equals to 32. So there, we wrote the equations. It's right here, right? And if that makes sense, make that make sense, okay? And then it says here, you graphed them. So here's the 2 lines that you graphed, right? And you should remember how to graph them. So it says the graphing of these 2 lines representing these equations is shown. What is the solution to the system of equations? Now, when I'm looking at a graph, what is the most important part? And you're like, oh, you keep saying this. It's the intersection point, Ms. Johnson. Very good. So I want to look at this intersection. It looks like 6 small boxes. And it looks like it's 5, but I'm going to verify with my answer. So I think it's 6, 5. 6 small and 5 large. Okay. And then I'm going to plug in and check my answer, right? So when I check my answer, I'm going to plug this into my equations over here, just like we did before. Is 6 plus 5 really 11? And you're like, yeah, let me write this down. So this is me checking it. So this is me check. 6 plus 5 equals to 11. And you're like, yes. What about 2 times 6 plus 4 times 5? Is that really 32? And you're like, yes, Ms. Johnson, that really works. Very good. So the whole point of this lesson is just to know how to read a graph of a system of equations. You should have known, or you should have learned in this lesson, that when you're looking at the graph, you're looking for the point at which they intersect. Okay. All right. Have a great day.